We start off with a basic problem where it says we're trying to figure out how much money each person has. Now, the questions say to solve each problem using only one variable, and we're going to do that. And I always start by kind of reading through. Judy has $12 more than Barbara. Together they have $58. As we look, we see that we have two amounts here, and then it says how much money does each girl have. That will give us an indication as to what the variable should be. I can say let x equal the amount of money. I'm going to say in dollars just to be specific, but if you use the dollar sign, that's fine. The amount of money in dollars Judy has. Now, we can be open to changing this because it says Judy has $12 more than Barbara right here. So if Judy has $12 more than Barbara, I have one option. I can either say, let's then do, see, Judy has $12 more than Barbara. That means that Judy has more. So if I subtract 12 from the amount that Judy has, I'm going to get the amount of money in dollars that Barbara has. This is obviously not the only way to do this, because I could then say a different variable, let y be the amount of money that Barbara has, and then y plus 12 could be the amount of money that Judy has. Either way is fine. I just started it this way, so it says together they have $58. Together is an addition thing. That means that something plus something else. So if I take the amount of money that Judy has plus the amount of money that Barbara has, and together they're going to have $58. We can go through and solve that. I can drop the parentheses because of the associative property of addition. And then we can add 12 to both sides. I have 2x is equal to 70. Divide both sides by a 2. X is equal to 35. And as a final answer, I would say that Judy has $35. And I'll do a second sentence of Barbara has 35 minus 12 is 23. And that can be my final answer. Moving on to the second one, we have a school bookstore that sold 3 more pencils. Here's another number. Then twice the number of pens in one day. The cost of a pencil is 25 cents. The cost of a pen is 45 cents. And our total for the day, total of pens and pencils, was $26.40. It wants to know how many pencils were sold. Again, if it wants to know how many pencils were sold, I can say let x equal the number of pencils sold. Now, I also want to know how many pens were sold. So if I kind of look at that, it says it sold 3 more pencils than twice the number of pens one day. So this is a little bit of a tricky phrase to sort of dissect. 3 more pencils than twice the number of pens one day. Well, what I sold were, if I take twice the number of pens, I'm just going to kind of sketch this down as a 2p, and then if I add 3, that should be the number of pencils. So this is a little tricky. I have another variable here. I have p for pens. So what you kind of should be open to is sort of scratching this out and saying, let's do something different. Let's say let p equal the number of pens sold, and then my 2p plus 3 is the number of pencils sold. Notice how I didn't scratch this out like crazy. I just kind of put a single line through it so that I could see what I was thinking, but I was able to revise that and change that because I saw by this first sentence it was far easier to set this up with the number of pens than the number of pencils. Once we have that, then it says the cost of a pencil is 25 cents and the cost of a pen is 45 cents. And then we have a total amount for the day. Well, if I have 25 cents, I want you to think about that. That is actually a dollars per pencil amount. And this 45 cents is a dollars per pen amount. Those are not strict amount of money. That's a cost per unit. Meaning if I took this, now this is sort of like a rate almost. And if I took that rate, that 25 cents, and I multiplied it by the number of pencils that you would have, the 2p plus 3, then if you added the same thing, 45 cents for the pen, times the number of pens, which was just p, then you're going to have the total amount of money you made for the day. And that equation should make sense. The cost of the pencil times the number of pencils plus the cost of the pen times the number of pens is equal to the total amount you're going to make for the day. Now you look at this equation and you see the decimals in play here. A couple of things we can do. One of the things we can do is we can figure out in terms of a strict fraction what fractions these are. That's 1/4. And then 45 hundredths would simplify to, let's divide both by 5, I'd have 9/20ths. So if I wanted a simple way to make this problem a little bit easier to work with in my head, and we have the 26.4. That one I'm going to keep as 26.4. Well, if I multiplied by a 10, that would take care of this one. If I multiplied by a 20, that would take care of this one. I have a good solid least common denominator of 20 here. And see, I figured that out by looking at the different fractions, 1/4, 9/20ths, and this one I didn't really have to think about what that would reduce to. I just know that swinging that over there would be, I could multiply that by 10. So let's do that. If I multiply both sides by a 20, look what happens. I have 5 times 2p plus 3 plus 9p equals, and then 26.4 times 20, well, that would be times 2 with the decimal moved over. It should be 528. If you can tell, I'm trying to solve this without using a calculator right now. Then we're going to distribute this. 5 times 2 is 10, and then 5 times 3 is 15, plus 9p is equal to 528. I have 19p plus 15 is equal to 528. Subtract 15 from both sides. 19p is equal to 513. And then if I take 513 and divide it by 19, 19 goes into 51 twice. 133, which is close to 140. 20 times 140, so let's try 7. 63, and yep, so p is equal to 27. Go back up here. How many pencils were sold? Well, I have p as the number of pens, so let's just do a simple 2 times 27 plus 3. It's 54 plus 3, or 57 pencils sold. But I don't want to leave it like that because you should never start a sentence with a number. So I'm going to spell it out. We're going to say 57 pencils were sold. You could also say he sold 57 pencils. Was it a he, or it was just a they? You could say they sold, and leave it as that. So either of those two sentences would be fine. Moving on, we're going to talk about 3 different types of distance relationships: motion in opposite direction, motion in the same direction, and the round trip. Let's start with number 3 and just kind of figure out which one this is talking about. You have 2 cars headed towards each other on a divided highway, so they're not going to crash, but they're 250 miles apart, so that's our first number. One car travels at a rate of 45 miles per hour, and the other one is 10 miles per hour faster, and it wants to know how many hours the cars will pass each other. Well, something I'd like to figure out when it says how many hours is, do they start at the same time? And they do. We're kind of taking this snapshot at the same time, so I'm just going to say let t, which I tend to use for time, equal the number of hours each car travels. T is the number of hours that each car travels. And this is an example of motion in opposite direction. So if I have car number 1, here's my little sketch of a car, and it's going this way. And I have car number 2, and it's going this way. Then each of those little bars, or each of those little line segments, can be represented as a rate times a time or a distance, depending on how you look at it, because we all remember from Algebra 1 that distance is equal to rate times time. Specifically here, our distance is in units of miles, and that's equal to the rate, which is in miles, I should use an MI, miles per hour, and the time would be in the number of hours. So miles is equal to miles per hour times the number of hours. So for this problem, I have a total distance here of 250 miles. So this big line segment is going to be 250 miles, which means that I don't know what each of the little distances are, but I'm going to represent them. I have, let's see, one car travels 45 miles per hour. So this one could be 45 miles per hour times its time, rate times time. And the other one is 10 miles per hour faster. Well, that's just 55 miles per hour times the same time, because they both go for the same time. So one rate times time is 45t, one other rate times time is 55t, and this one we don't represent with a rate times time, that's a distance. But distance is equal to rate times time. So I essentially have rate 1 time 1 plus rate 2 time 2 is equal to total distance here. But really that equation is somewhat unnecessary. We just kind of, well, I'll leave it there. We just want to sort of sketch this out. 45t plus 55t is equal to 250. Add the two of them up. You have 100t is equal to 250. Divide. We can cross the zeros out at 25 tenths, which is the same thing as 5 over 2. And we'll make this one a decimal, even though we don't like them that much, 2.5 or 2.5 hours. So the cars pass in 2.5 hours. Now, back up to this motion in opposite direction. We have a couple of things here. We have, I could say this whole rate 1 time 1 plus rate 2 time 2 is equal to the total distance. I could say we do have a total distance. That just kind of gives you an idea of it. We could draw pictures like this, or we could draw pictures where they're moving away from each other and the same thing kind of applies. Either way. So those are just some sketches that might help. Number 4, we have Carla beginning to bike south at 20 kilometers per hour at noon, and Dean leaves from the same point 15 minutes later to catch up to her. Let's look at our numbers here. We have biking south. There's a rate. Dean leaves 15 minutes later, and Dean bikes that much, and it wants to know how long will it take him. That's kind of important. How long will it take him? Because when I set up my variable, I'm going to say let t equal the number of, I've got hours here and I have minutes here. I'm probably going to want to keep it in hours. So I'm going to put a little parentheses here, and we're going to say 1/4 hour, because 15 minutes is 1/4 of an hour. I might even sketch that out just to remind myself that I want to use the 1/4 hour. We're going to say t is the number of hours it takes Dean. So we got biking south, and we have someone catching up. So let's talk about Carla. Carla bikes south. Carla bikes south. She is biking at a rate of 20 kilometers per hour, and she is biking for a time of, well, the time is not t. She's leaving 15 minutes earlier, which means she bikes for 15 minutes longer, but that 15 minutes should be represented as a t plus 1/4, because she, well, we can't use minutes. Dean starts at the same spot. His rate is 24, but Dean's time is t. Now, notice how they start at the same spot and they end at the same spot. In this case, we have a rate 1 and a time 1, and that's equal to a rate 2 times 2, which is equal to a total distance. So I'm going to go back up. This is motion in the same direction. We'll put this sort of arrows down like that. We can also put arrows to the side. Rate 1 time 1 plus, or equals rate 2 time 2 equals distance. Now another thing I might put here is that you notice how Carla has a slow time, or sorry, has a slow rate, but gets more time, whereas Dean has a bigger rate but less time. So I'm going to say less time times fast rate, and that's going to equal more time, and slow rate. So think about this like a race. Multiple people run a race and they run the same distance, but the less time is the fast rate, and the more time is the slow rate. So this kind of helps us set it up down here. Carla's rate is 20 times her time of t plus 1/4 is equal to Dean's rate of 24 times the time of t. And then we're just going to solve this algebraically. 20t plus 1/4 of 20 is 5 is equal to 24t. I like to work things on the left side even if they're negative. So negative 4t is equal to negative 5, and t is equal to 5 over 4. Since this is number of hours, we're going to say 1 1/4, or I could say 1 hour and 15 minutes. So as a final sentence, it takes Dean 1 hour. I don't like to write 1, I like to spell it 1 hour and 15 minutes. Okay, next we have an investment problem. If you've ever invested money, sometimes you split that into two different, and this is going to be split. And whenever you have a split here, we're going to think about what the split is that one thing we're going to put it in. I'm going to split this into an x and split it into a total minus x. We're not going to use x and y yet. You need to learn how to do this with one variable, and we're both going to make you do this with one variable for the time being. So as a let statement, I can say let x equal the amount invested at 5.5%. And then I'm also going to say, well, I don't like to put let there, but we're going to say 6,000 minus x is the amount invested at 7%. Oops, and that wasn't 5.5%, that was just 5%. That makes this easier. The annual interest income is this. Well, if I take investment 1 and I multiply that by the first interest rate, and then I take that and add it to investment 2, and I multiply it by the second interest rate, I get the total interest. And the total interest is small. I mean, you don't make $6,000 back. You just make a part of that. $372 is actually a pretty good amount to make off of $6,000, even in today's market. So investment number 1 was the x, and the interest was the 5%. Well, that's 0.05 expressed as a decimal, and multiply that by x. And then I'm going to take the 7% and multiply that by the 6,000 minus x, and that's going to be equal to the 372 total. 0.05x plus, let's see, 0.07 times 6,000 is, that'd be 7 times 6, but then kill 2 zeros, so 420, minus 0.07x is equal to 372. Simplify the left side, that leaves us with 0.02x. Subtract the 420 over, and that's equal to negative 50. And if you multiply by 100 but divide by 2, we get 2,500. So it says how much did he invest at each rate? He invested $2,500 at 5%, and 6,000 minus 2,500 is 3,500 at 7%. Okay, last one. Let me circle this. This is a mixture problem. This is a common type of mixture. In essence, an investment problem is also a mixture problem. So this is very similar, at least in how we set it up. Food processing company produces grated cheese that made from Parmesan and Romano. Parmesan costs $3.50 per kilogram. Romano costs $5 per kilogram. And it wants to know how many kilograms of each type should be used to produce 100 kilograms worth that much. That's a lot of information in here. You might not be thinking about how to organize it all. Well, let's start with the variables. How many kilograms of each type? So I should have kept these bottom ones a yellow highlight to be consistent. There we go. How many kilograms of each type? Well, we're going to let's let P equal the number of kilograms of Parmesan. So then we need one for the Romano, and we're only allowed to use one variable. Well, this is kind of like the money thing. I have 100 kilograms total. Some of that's going to go to Parmesan, and the total minus that is going to go to the other one. So this isn't 100 minus x, this is 100 minus p, the number of kilograms of Romano. See, now we have an expression without using a second variable. Okay, now if we go back up to how we did this one way up here with number 2, this is like number 2, where we have a cost for something. This is the cost per kilogram. If I take Parmesan at $3.50 per kilogram, so $3.50 times the number of kilograms, and I add the $5 that Romano is times its amount, 100 minus p, I'm going to get, now here's the little difference here. What I'm getting when I multiply $3.50 times p, the cost per kilogram, times the number of kilograms, is I'm getting a cost. We know that, but look at what's happening here. This is different right here. Sorry, I'm going to use another highlighter. This 100 kilograms of the mixture were $3.95 per kilograms. That doesn't tell me what my total cost is. I need to actually have a total cost, which is the same thing as the 100 kilograms times the $3.95 per kilogram. Or I should probably reverse those to make them match what came before. $3.95 times the 100. That's actually a total cost. That's how much the whole thing's going to cost. It's not $3.95. It's $3.95 times 100. It's $395. So let's simplify that and clean that up. That satisfies step 2. But for step 3, let's just kind of move and simplify this down. 350p, or I should just say 3.5p, plus 500 minus 5p equals 395. Now, I don't typically like working with decimals, but we'll go ahead and subtract. 3.5 minus 5 is negative 1.5p, and then subtract this over, and I get negative 105. Now, I still don't like working with these, so we're going to cut the negatives. We're going to multiply both sides by a 10. I like that better. And then I'm going to go ahead and divide. P is equal to 105 divided by 15 is going to be 7. Yep. So that's going to be 7. And then that goes into it 0 times. So 70. So P is 70. That works. And it says how many kilograms of each type should he use. So they should use 70 kilograms of Parmesan and 30 kilograms of Romano.